Well, welcome back, folks. Today we're going to talk about a project I'm working on for my good buddy Jim. This is a fabrication project for one of Jim's Harley Hummers. Now, I'm not a Harley Hummer expert. I know very little about them. But what I can tell you is they were originally made by Harley Davidson. Yes, the Harley Davidson. They were two-stroke from 1955 to 1959. However, the term Hummer has now been coined to really include all two-stroke Harleys made between 1948 and 1966. So technically, the Hummers, or the term Hummer, applies only to the 59 and 59 models, but it's been standardized for all those two-strokes that Harley used to make. Jim has been a Harley Hummer fan since he was a kid, since he was a teenager. I've never worked on one, I've never ridden one. Why don't I go ahead here and I'll insert a photo briefly at this point for those of you that, for the benefit of those of you that have not really seen a Hummer before or really don't know what I'm talking about. So let's take a look at this, this stock photo of an original Harley Hummer. The original design for the Hummer came from out of World War II. It originally was designed, as I understand it, by the DKW company, and as part of the War Reparations Project post World War II, the design for the Hummer, for the small two-stroke, was absorbed into a couple of different Western European and US-based manufacturers, that being, of course, Harley, and I believe BSA from the UK also adopted a version of this DKW design engine. Jim's project, and the parts here that we're talking about are for the swing arm. This is the chain adjuster, one of the two, of course. And what I've been asked to make, what Jim has asked me to do, is to fabricate a, I don't know if you'd call it a holder here in my right hand, but this piece right here, the small piece that's been sawed off, Jim cut it off or ground it off his frame because it was, you can see one of the two ears. This is a U-shaped piece, fits something like that on the bike, and this one ear is broken off, and my understanding is this adjuster fits into or over this adjuster I'm talking about, fits over or into this slotted piece which is mounted in the frame. And this is, I think, tack welded into the frame, and then this is used to somehow or other adjust a chain. And again, I'm not familiar with the mechanics of it, I've never worked on one, but Jim has asked me if I can fabricate a new one of these little U-shaped pieces, and because of obviously the broken ear, for his restoration. It's really not a restoration. I think he's working on a custom using original parts. So that's exactly what we're going to do. I'm going to take this piece and use it as a model, and between my mill and my lathe I'm going to make a new one of these little pieces, and then Jim will re-weld it, mount it, and re-weld it on his frame before he paints it. I think he's probably going to powder coat it, but I couldn't swear for sure. Pretty simple project. There's not really a lot to it. I think the first thing I'm going to do is clean this up on the wire brush because I'm going to need to get some dimensions off of it, and I want to start with as clean a metal as I can get. It's not critical in terms of the dimensions. I think as long as we get close or in the ballpark, it'll be perfectly fine for this project, but I will, try to do the best I can with what I've got to work with. Jim did send along a little piece of square stock and as the material to work from, though I probably could have rounded up something out of my junk box, but he did send along the material to start with, and we'll talk about that in just a second. So I'm going to go over to the wire wheel. I'm going to clean this up a little bit, and then we'll come back and we'll do a little referencing of dimensions so we know what we're working with before we move over to, I think, the lathe and get started on this. Just finished a couple minutes on the wire wheel, got her all cleaned up, or at least cleaned up enough to get some measurements and dimensions from. You can see the remnants of a little black paint, I think there. as it was originally done in black. I've also done a little measuring of my simple little caliper here and made this little working sketch. I don't always use a working sketch for this kind of a project, but I thought it might help. There's a number of different dimensions. For those of you that are experts in drafting, you're going to have to forgive me. I did have drafting years ago. I mean, we're talking almost 50 years ago, I think now. I had drafting in school and high school. That's the days, of course, we used literally wooden boards and pencils, real pencils, and slide rules and those kind of things. And I did learn the basics of drafting, though this drawing might not reflect that. All these dimensions, by the way, are in imperial, not metric, because I believe this original part, being the age it is and made in the USA, was originally dimensioned in imperial, otherwise known as inches. So I've made the drawings based on some of these dimensions, as you can see here. It's a little busy, I know. I didn't spend the time to try to put it together the way a real draftsman or draftsperson would these days, but it certainly is functional enough for my purposes. I think the first thing I'm going to do, and here, by the way, is the stock that Jim provided me, which is just about perfect in terms of, I think this is 1/2 inch material here. And if you notice, some of these dimensions are getting really close to 1/2 inch. I'm not going to try to make a perfect copy of using these dimensions. What I'm going to try to do is get it reasonably close. I'm not sure the dimensions I took were exactly perfect because of wear on this original part, and there's some burrs and those kind of things that have gotten in the way a little bit. So I'm going to take these dimensions as nominal or targets, not literal. I'm probably going to use this square stock again. I think this is about 1/2 inch. I haven't measured it yet. Let's see what it is. Yeah, it's 1/2 inch raw material is what it is. This was just a piece of simple hot rolled steel. It did have scale on it. I think you can probably see it there. It did have scale from the manufacturing process, and I wire brushed that all off too to get it down nice and clean steel. So we got a piece of 1/2 inch square, and I think I'll just use that as my working dimension here for this 0.437, 0.439, and I'm not going to dimension any further beyond this. I'll leave the standard dimensions. In other words, I'm not going to machine this. What I will machine, of course, is these features. I've got to make this cutout here. The length, I asked Jim how long this round protrusion that fits into a hole in the frame that spot weld on the back is supposed to be, and he said just make it as long as I needed to be able to hold it and machine it, and then he could cut it to size. So to make it simple for myself, if you take the 0.610 and the 0.400, add them together, it comes up to just over 1 inch or 1 inch. 110 thousandths. I think what I'm going to do is make this, add those together, it comes to about 1 inch. So I think I'm going to make this piece about 1 inch long here, eventually. First thing I'm going to do though, I think, is chuck it up in my lathe in a 4-jaw chuck and machine this feature. In other words, this round protrusion or stub that fits into the frame. It measures out at 0.310. I did check it with a 5/16 drill bit, and it's very, very close to 5/16. In fact, I think 5/16 is probably what it was originally. 5/16, I think it's just under that. In fact, that is about 5/16, as you can see there. So I think a 5/16 dimension for this round nipple or stub will be just about perfect. So I'll have to put it in a 4-jaw chuck, and then 4-jaw is a little bit more complicated than 3-jaw because I have to center it in both horizontal and vertically in order to get it to run true, and then machine this back, like I said, probably around 400 thousandths of an inch or so. And then I can remove it from the chuck and take it over to the mill, and then I'll basically have to cut the slot down the middle. That's the gist of what I'm going to be doing. So I'll go over to the lathe, set this up in a 4-jaw chuck. It's going to take me a few minutes to get that squared up, and then we'll pick up the video over. Set up over at the lathe. I've got the basic setup all complete. I've got the part in a 4-jaw chuck, and I've got it dialed in. That is, I've got it equalized, the part. Right here is the part, that square piece of hot rolled steel. I've got it positioned in the vise in such a way that it's within a thousandths in both dimensions, so it's plenty close enough for this little project. We're not making parts for the space shuttle after all, so thousandths is well within reason for something like this. You will notice also that I've removed my shirt, my long sleeve shirt. Even though I had the sleeves rolled up a bit, and my jewelry, you never, ever, ever, ever want to operate a lathe, drill press, milling machine, or anything that's under power that's got spinning components or spindles. It's a good way to get yourself seriously hurt if something gets snagged and you get pulled into the machine. You will be seriously injured quicker than you can blink an eye. So all jewelry, all long clothing gets removed. I faced off the part. Wasn't entirely necessary, but I did square up the end. That's the facing part. And then I measured back about 400 thousandths of an inch. That's just a nominal measurement. And what I want to do is start sizing this end here to the right, and bring that down to about 5/16 of an inch or so, like 310 thousandths, something like that. I have to look at my drawing to be sure, and I'm going to bring it plenty deep. You can see as long as I'm to the left here with my tool of that mark, I've got so much to work with here, it's not going to be critical. Now this is an interrupted cut, and what that, at least initially, and what that means is when the part spins, since this is a square shank part, I'll be cutting initially only on the edges, and then when it passes like this, it will no longer cut for a bit. It'll cut, no longer cut, etc. That's an interrupted cut. It's not nice and smooth, and you'll get a thumping sound out of it initially until it gets brought down in dimension enough that it truly starts to become round. Now, depending on your tooling, you don't want to use typically carbide tooling, and I do have carbide tooling. I've got a fair amount of it. This is a carbide bit right here. Carbide doesn't handle interrupted cut. It's so hard and brittle that it'll tend to chip. So I switched over to a high-speed steel. This is a good quality high-speed steel tool. I would prefer to have a little bit larger shank for this type of cut, since it is going to be a heavy cut with that interrupted nature of what I'm going to be machining. But this is the only toolbar I have that I have high-speed steel tooling for. So I'm going to have to take it slow and easy, otherwise you're going to get a little bit of movement of the tool. Again, it's not ideal, but it's what I've got to work with right now, so that's what we're going to do. So I'm going to put a little bit of cutting oil on here. I've already got my carriage stop set to the motion to the left, so I can just bring it back to the carriage stop every time like this and don't have to worry about measuring. And we'll go ahead and get started. Now, I'm not going to show the whole process because that could take some time, but I will show you bits and pieces of it as we progress along. As you can probably see here, I'm just about got all the corners off. Now it's turning into a true cylinder, Right now the finish isn't very good. I'm not too concerned about that. I can clean that finish up later. Right now I'm just trying to get material off. But we're just about down to truce cylinder. So I'll continue on now with refining the size down till I get to that 310 5/16 dimension. And then this basically will be done. I'll clean up the finish at the very end. Up over on the mill, you can see I've got the little piece chucked up in the chuck, got it all squared up, and I've brought it to length. That is this dimension here, which is approximately 610 thousandths. I left it just a fuzz long, maybe 1 or 2 thousandths intentionally, but you can see there it's pretty close. So now that I've got the length set, what I've got to do now, or what I'm going to do now, is I need to find the center of this piece. I'm going to use a center finder for that. I'm going to mill in this direction. I don't want to, because I'm clamped on that round shaft, I don't want to twist this part like this, so I'm going to use the jaws to my advantage. So I'm going to mill this way. And I think I'm going to use a 1/4 inch mill for that. I believe this original dimension inside here, as I think I talked about, was about 5/16 of an inch. So I don't have a 5/16 mill, so I'm going to come in with a 1/4 inch, and I got to determine my depth yet. But I'll come in the 1/4 inch after I've got it centered, and then I can move back and forth on each side of the center just enough. So 5/16 is obviously a 1/16 of an inch bigger than a 1/4 of an inch. So I've got, what, 62 thousandths or so I've got to take off, split that in half, 31 thousandths or so on each side, and I can do that by just traversing the mill. I can watch my DRO or my digital readout move back and forth. It's just enough to open it up to that final dimension of 5/16 or so. I will use the actual adjuster itself to ensure fit before I break down the setup when I'm all done. But what I'm going to do now is I've got to find the center of this piece this way laterally, and then I change my milling head out, or my mill bit out to 1/4 of an inch, and then we'll go ahead and get started with the milling. I've got my setup complete. I've got the part, or the tool, the center line of the tool, centered in both dimensions or directions, X and Y. I'm going to cut in this dimension here, this direction, which is the most important of the two to get centered. I have the height set. I have my Z-axis carriage stop set so that the vertical direct, that's the Z-axis, the vertical, I will go down to about 215 thousandths. I'll leave that much meat left here. I think I measured the piece right here. I think I measured this at around 213 or so, but I'm going to go, I think, to 215, leave a little bit to work with there. So I think we're about ready to go. Now, obviously, with this 1/4 inch .250 milling tool, I'm not going to take it all in one pass. I'm going to work my way down till I get to that 215 thousandths dimension. So I'll take my time and just work my way down carefully. And then when I'm done, I will do a test fit of the adjuster that Jim sent along and see how it fits in the slot. And again, if I have to, I can move back and forth a little bit to open it up to make it comfortable. Well, there's my last pass. I've got my vertical dimension set, of course. That's around 212, 213. I've come to depth, and my ear width here, I've been checking in as I've been going. The original part right here measures, it varies a little bit, but depending on where you measure, it measures up to about 92 or so thousandths right there, 93. And I've got this part to pretty close to that same dimension. It's 102, so it's off by about 10 on that side. And about 11 thousandths on that side. And that's perfectly fine with me because I've got plenty of room for this adjuster to fit in there, as you can see. And I'd rather leave a little bit of more meat on these ears than take them down too small, because that's what actually, after all, happened to the first one. One of the ears broke off. You can see right there. So I've got plenty of room for that adjuster to fit. So I think the part's just about ready to go. So I'm going to pull it from the vise. I'm going to deburr it a little bit because obviously some burrs. Hit it with a little file to soften the edges, and then we'll take a look. Well, I have the piece pretty well done, as you can see there. Took a couple files, spent probably 20 minutes deburring it, breaking the edges, cleaning it up a little bit. And I think you can see there how it turned out. Let me see if I can lay these pieces out for you here. I think you can see that right there. Dimensionally, it's within 3 or 4 thousandths, pretty much in every dimension. The only exception to that is I made it just a touch wider this way than the original. And the ears, and what I'm going to call the ears right here, that's what engages with the adjuster. I made them just ever so slightly thicker. Since this one failed, I didn't want this one to fail also, so I added just a touch to the width here and the thickness here, each of the ears. But other than that, it's virtually identical in terms of size. The shaft size, this stud right here that's welded into the frame, this dimension right here, etc. And I think it came out really good. Altogether, I probably have maybe 3 hours into it. I'm a little rusty on the mill. I haven't used my mill in a while, so I had to kind of get my head back in the groove. But once I did that, everything came out just fine. So what I think I'm going to do now is I'm going to clean this up a little bit, get all the machining oil off of it. Oh, by the way, you can also see I just skimmed each of the flat sides. I think you can probably see that right there. Just skimmed them to flatten them off, that's all. Because they weren't necessarily flat, of course. But I'm going to clean this up, degrease it, get the oil off it, and I think I'm going to hit it with a little bit of primer. I don't know how long it's going to be before Jim gets around to installing this in his project. It could be months. And just to head off any potential rust, I'll just hit it with some good quality primer, and then it'll be good to go. And then whenever he gets to it, he gets to it. I'll put a photo here at the end showing the piece after it's been painted with primer. That's going to be it for this little shop talk video today, folks, making this little holder for the adjuster on a Harley Hummer. If it's something like that, of course. Any issues, questions, thoughts, drop me a note. Otherwise, as usual, thanks for watching.